Finding missing angles in quadrilaterals. This is going to be a step-by-step process that will help you find any missing angle in any quadrilaterals, but there are a few key things you need to remember. First off is that if you add up all the interior angles, that's the stuff on the inside, for a quadrilateral, it is going to equal up to 360 degrees in total. Another thing that will help you out is the knowledge of quadrilateral rules. If you haven't taken some time, go back and watch my video on quadrilateral rules, what makes them what, because that can really help you finding missing angles. Now the first thing I'm going to tell you to do is to add up what you know. So you're going to start with adding everything that you know and seeing kind of what you got from there. You know the end game is hopefully going to be 360 degrees, so figure out what you have, figure out what you're missing, and usually somewhere along the lines you'll be subtracting from 360. So for example, this thing that ends up being a really ugly, but it's an ugly trapezoid, because you have one set of parallel lines that would go on and on forever without touching. But you need to figure out what you have. Well, I know I have 100 degrees right there, and then I have 60 degrees. I'll do it in white so it's a little bit easier to see. So I have 100 degrees here, I have 60 degrees here, and I have 55 degrees here, and I'm missing something, x. If I added it all up, we're hoping it's going to equal 360 degrees. So let's see what we have. 100 plus 60 is going to be 160 degrees, and 160 plus 55 degrees, I can't really do that one in my head really well. 160 plus 55, 6 plus 5 is 11. So if I added up 160 plus 55, that gets me 215. So I have to figure out what can I add to 215 that would get me 360. Now I can figure that out through addition and just kind of plug it in numbers. Or another way that works a little bit better is that you can subtract what you have, which is 215, from 360 and see what you get. I have to borrow. That 6 changes to a 5, changes to a 10. 10 minus 5 is 5. 5 minus 1 is 4. And 3 minus 2 is 1. So that means that the missing angle here is 145 degrees. So x would equal 145 degrees, which would make sense because just looking at this angle, look, you see how open this door is. I know that that's an obtuse angle, and I know obtuse angles are going to be greater than 91 degrees, so that answer tracks. So my missing angle measurement is 145. We added up what we knew, and we took it away from 360. Using that, it's going to take a little bit more thinking. We have 105 degrees here. We have 94 degrees here, both obtuse. Now this angle, I don't want to say it's really special, but you know if they put this sign in an angle, that means it's a right angle, which means that it's 90 degrees. So they did give you enough information to find out what's missing over here, which is my y. Now just looking at that, I know that y looks like an acute angle, so I know my answer should be less than 90. I'm going to keep that in the back of my head. And let's add up what we know. Well, we know we have a 105, we have a 90, we have a 94, we have a missing angle, that's y, and we know that if we add it all up together, it's going to be equal to 360 degrees. Starting off first, I'm going to do 105 plus 90. That would equal 195. I'm going to then have to add 195 plus 94. I cannot do that in my head, so I'm going to make some space. Plus 94. 5 plus 4 is 9. 9 plus 9 is 18. 1 plus 1 is 2. So I have 289 plus my missing number should equal up to 360 degrees. I can try to figure that out through plugging in numbers to see what I could add up, or I could think about it as a subtraction. I will take away what I know from 360 and see what I'm left with. This problem's a little bit harder, not because I'm changing anything of what I'm doing, it's just because I have a little bit more difficult numbers to work with. So that 6 changes to a 5, That 0 changes to a 10. 10 minus 9 is 1. I can't do 5 minus 8, so that 3 changes to a 2. That 5 changes to a 15. 15 minus 8 is 7. So I get the answer of 71 degrees. So my y is equal to 71. Does that answer make sense? I think so, because I know 71 degrees is an acute angle, and y must be an acute angle. Now that we're on to the third problem, we are going to go over how the knowledge of quadrilateral rules are really going to help you for number 3, because you don't have a ton of information, but if you know quadrilaterals and you know their rules, you can get some more important information. To me, this looks like a parallelogram or a rhombus. It looks more like a parallelogram to me because one side looks longer than the other, but I do know some rules about parallelograms. The opposite sides are parallel and equal. The opposite sides are parallel and equal. I also know, which is going to be super important for this, that the opposite angles are also equal. So A and C are going to be equal, but more importantly for this information, B and 64 degrees is going to be equal. So without doing any kind of work, I know that angle B is going to equal 64 degrees because opposite angles are equal in a parallelogram. So I have two angles that are there, 64 and 64, but unfortunately I have two missing angles. So how would I set up that problem? Well, let's think about what we know. We know that 64 plus 64, if I added it up, 4 plus 4 is 8, and 6 plus 6 is 12. So I know that 64 plus 64 degrees is 128 degrees, and I'm going to take that number away from 360. Say, well, why are you doing that? Well, let me do the quick subtraction first. The reason I'm doing that is because I'm taking what I know away from 360, because if I added up A, B, C, and that 64, it's all going to be equal to 360 degrees. I'm going to take away the two angles, and that means I'm left with 232 degrees, but this amount of degrees has to be broken up evenly with C and A. So what I'm going to have to do is I'm going to have to take that number and break it up evenly amongst my two angles, which means I'm going to have to divide this number by 2. So let's do some long division, as fun as that might not be. 232 going into divided by 2. 2 can go into 2 one time. Subtract, bring down. 2 can go into 3 one time without going over. Subtract, bring down. And then 2 can go into 12 6 times without going over. Subtract, bring down. I have nothing left. So that means that my two angles will equal 116 each, because I split up 232 into two groups because I have two angles, angle A and C, I have to find the answer for. And I found out that each one of those angles is 116 degrees. So just based off my rules of quadrilaterals, I was able to find out, without doing any work, that B is 64 degrees and that A and C are equal. So that helped me set up all problems. So a couple important things you need to remember. Quadrilaterals, whenever you're starting, 360 degrees is going to be the interior angle measurement for all of them. And then knowledge of quadrilateral rules will help you. I'm also going to circle number 3, because if you follow me for a YouTube short, I can tell you how to solve every parallelogram and every rhombus angle measurement super quickly. If you want to know, go to the description. I will have a shortcut, or I have a link to the shortcut for a YouTube short video. Thanks for watching as always. Don't forget to like and subscribe.